Hi, Mrs. Jacobs here to go over the answer key to the worksheet from yesterday. Most people wanted to see problems 3, 4, and 5. So I'll just show you quickly problems 1 and 2. In problems 1 and 2, there were two forces, Ft and Fg, and they were equal because this is a balanced force situation. Over here, you plug in 3 kilograms as the mass into the Fg equation. You multiply it by 9.8, and you get that Fg is 29.4 newtons, which is the same as Ft, 29.4 newtons. Number 2, it's the same free body diagram and the same force equation. The difference is you don't know the mass. You do know the tension. So if tension is 200 newtons, Fg is 200 newtons. Then I take 200 newtons and I plug that in for Fg. I divide by 9.8 on both sides, and I get 20.41 kilograms as the unknown mass. Number 3 and 4 are more challenging because there are 3 forces acting on each object. This man is trying to lift the pumpkin, but it's still at rest. So it's experiencing 2 upwards forces, an Fn by the floor and an applied force by the man, and 1 downward force, the Fg, by the earth. You can see I've got the interaction diagram here, my free body diagram, and then now my force equation is Fg equals F applied plus Fn. If I'm going to solve for all forces, the first thing I'm going to do is I'm going to start off with Fg. So let me copy and paste this equation down here. I was given the mass of the pumpkin as 300 kilograms. So I do 9.8 times 300, and I get Fg is 2,940 newtons. The other thing that I was given in the problem is the applied force of the man, Fap, is 600 newtons. So the final force that's remaining to solve for is Fn. And to get that, I have to use my force equation for my free body diagram. I know that Fg equals Fap plus Fn. Force of gravity equals applied force plus normal force. So I'm going to put in my Fg on the left side, 2940 newtons, equals 600 newtons plus Fn is my unknown. You're always going to have to use this force equation from the free body diagram at some point, and in this case, I'm using it to solve for the normal force. So to solve for Fn, I'm going to subtract 600 from both sides, and I get 2340 equals F. And now I have solved for 3 forces, Fg, F applied, and normal force, and I'm done. The pillow situation is similar. The difference is the student is pushing down on the pillow, not pushing up. So there's an applied force down on the pillow by the student. There's an Fg down on the pillow by the earth, and there's an Fn normal force on the pillow by the floor. So my force equation is the one force up, Fn, equals F applied plus Fg. I'm still going to start off by solving for Fg. I do that. Let me copy and paste the Fg equation. If I know mass, I can always solve for Fg, and that's a great place to start. This time it's 4 kilograms is the mass of the pillow. And 9.8 times 4 is 39.2 newtons. The other force that was given was the applied force by the student. Fap equals 150 newtons, and I'll just say that's a given. So the final force to solve for is the normal force. But this time I have Fn equals Fap plus Fg. Fn is unknown. F applied was 150 newtons. Fg was 39.2 newtons. So to solve, I just add those together, and I get that the normal force is 189.2 newtons. The last problem had the two objects touching each other, A and B. We've drawn this interaction diagram before, and we've drawn these free body diagrams before, but we've never solved for all the forces. It's important to note that in the interaction diagram, box A only has two forces acting on it, Fn and Fg. But box B has three forces acting on it, two different normal forces and one force of gravity. So it has two downward forces, one by A and one by the earth, and one upwards force by the floor. The other important thing to note, whenever you have two objects, you're going to have to know the Newton's third law pair forces between them, because that's going to help you solve the problem. So I have one on A by B up, and I have one on B by A down, and those are in my Newton's third law pair forces, and I circled them. I also have my two force equations. I'm going to start off with the force equations for A. The mass of box A was 40 kilograms. So, don't need that. Go back up here. I'm going to copy and paste my Fg equation. I'm going to start off with my Fg equation. Mass of A was 40 kilograms. So the force of gravity of A was 9.8 times 40, which is 392 newtons. Therefore, that's also the normal force acting on A. So I've solved for both forces acting on A. Now, in order to solve for the forces acting on B, I first am going to do the force of gravity equation again. This time, the mass of B is 50 kilograms. So 9.8 times 50 is 490 newtons. Force of gravity on B is 490 newtons. But in order to solve for the other two forces, the two normal forces, I have to recognize that I already know one of them, and that's the pair force. If this upwards force on A was 392 newtons, then this other force on B by A is also 392 newtons. So the Fn down on B, I'll just say on B by A, is 392 newtons. And I'll just say Newton's third law pair force. So the only force that I don't know right now, I know the two downwards forces, Fg and Fn on B by A. I don't know the upwards force by the floor. To get that last one, oops, that's not what I wanted to do. I guess I'm just going to go on to the next page. That's fine. I'll say Fn up equals Fn down plus Fg. I don't know the Fn by the floor. That's what I'm solving for. The Fn down was 392 newtons. The Fg was 490 newtons. Therefore, I add those together, and the final answer is 882 newtons. Sometimes I think it's easier if you could just take what you know and write it in the free body diagram, because it helps you to see it. So for example, we solved for this one and we got 392 newtons. Therefore, this one had to be 392 newtons. Therefore, this other force, this other pair force, had to be 392 newtons. And then we solve for this force of gravity, which was 490 newtons. And then it's easy to see, okay, if I want to get the final force, I just have to take 392 plus 492, and I got 882. So I like to, once I solve for a force, just go ahead and write it right next to that force in the free body diagram, because I think it helps you figure out what you've solved for and what you still need to solve for and how to go about doing that. But I think you can see that it's impossible to solve these problems without the free body diagrams and the force equations. The FG equation really only helps you solve for FG. Everything else comes from your free body diagram. Hopefully this was helpful.